So now let's jump into the second scenario where we discuss about opening API access to external partners. So Travels as a company has been seeing a lot of demand from their partners who approach them to open up their Travels APIs so that the partners can leverage it to build more value added services. Travels obviously saw this as a great business expansion opportunity, but at the same time wanted to expose their APIs in a more sustainable and secure way. So, in order to achieve that, the strategy Travels devised was, they wanted to deploy two different versions of the Travels microservice, um, where the version 1 served the internal traffic and the version 2 would serve the external or the traffic that is coming from partners, which means they wanted all the partner calls, API calls, to flow through v2 and all the internal calls to flow through v1. And for this, they didn't have to do anything extra or didn't had to install any additional components. They decided to leverage the intelligent traffic routing capabilities of OpenShift service mesh for this, and in scenario 2 we'll be doing exactly that. So first, let's go to our OpenShift admin console and get the login command. Let's do display token. Let's go to this login command, Control C, and login. Here you go. Now we are logged in. Now we can run our OCCLI commands directly from our local machine. Let's go back to our instructions, and first let's deploy the v2 version of the travel service. Go ahead and I have a Kubernetes manifest file that will deploy my v2 in the travels agency namespace. So once this is deployed, if we go back to our Kiali and observe, you can actually see the traffic is being split between v1 and v2. Let's just give it a couple of minutes before we can see what's actually happening, right? But before that, before we see that image, what exactly is happening is that, service mesh, when it sees a second version of the microservice, it decides to split or load balance the traffic that is coming to that service between the two different versions if there are no other rules. So eventually what you'll see is, the traffic is being split between v1 and v2. You can see eventually these numbers will become 50-50. This is happening because, we've not yet told service mesh that, v1 should go, v1 is only for internal and v2 is only for external. What all we have done is we've just deployed the v2 version of the travel service, and next we are going to direct service mesh to take the action where it will strictly route all the internal traffic to v1 and external to v2. Let's see how to do that. So now after we've seen that, let's go ahead and deploy what we call a virtual service, which will actually tell service mesh to, send all the internal traffic to, you know version 1. So let's go ahead and apply that. And now if you go back to your Kiali portal and wait for a couple of minutes, you can actually see, even now you can actually see the traffic going down for v2, because the traffic simulator that we currently have is generating traffic exclusively from the internal portals, which is VIG, Voyages, and Travel. And as we can see, the number of calls made to the v2 is going down because, we've service mesh is telling any calls that are coming from internal portals will only go to v1 and not to v2 anymore. So we've made that rule. So you can see eventually you will not be able to see v2 in this graph as you keep refreshing and give it a couple of minutes. Eventually you'll not be able to see. So I'll just keep refreshing until we see 0%. So it's 7.6 right now. There you go. So you cannot see v2 anymore. That's because, all the calls that are coming to the travels API are only coming from internal portals and hence are only going through v1 because of the virtual service that we just deployed in service mesh. Now the next step is to tell service mesh, or is for service mesh to tell that any traffic that is coming from external partners should go through V2. So we have to do two things here. One is expose our API externally. We can use that. We can do that using the by using the Istio Ingress gateway, and also creating another virtual service which will redirect all the external traffic to V2. So now let's go ahead, copy these both OC commands and apply them. There you go, apply. And now you have to go back to your instructions and check if you can actually access the API externally now because Service Mesh has exposed the API through the existing inbuilt Istio Ingress gateway. You can actually access the API. External partners are now able to access the API. And let's generate a bunch of calls, say 50 calls, that will kind of simulate the traffic coming from an external partner. So I'm going to do that using a curl command and run it for 50 times. And now as we do that, remember we had zero traffic for V2. You can slowly see the traffic being increased for V2. V2 appears into the Kiali graph, and eventually you can see the traffic going up. See, you can see 50-60% of the traffic because we made a bunch of calls suddenly. And if you keep doing more calls, like if you run the same command another 50 times, you can see the number of calls going up for V2. And eventually once all the calls have died down, it'll go you can see all the traffic goes back to V1, because only the simulator that we have is generating internal calls, and if you want to do external calls, you have to manually generate them. So that's how we are actually intelligently routing traffic through V1 and V2, and service using the intelligent traffic routing capabilities of Service Mesh. We are able to differentiate the destination of the traffic based on if it's internal or external, and by leveraging the virtual services of Service Mesh, that is how we're able to achieve it. Now let's jump to scenario 3, where we'll talk about securing API access for north, south, or external traffic.